Hey everyone, a very warm welcome back to the channel. Today we have an amazing question from the chapter of AOD, monotonicity and maxima minima. The question says, f is a function from 0, infinity to real numbers. It is defined as integral from 0 to x of the function t power 6 minus t plus 1 cube into logarithm t plus 1 power 6 with respect to dt. And we are being asked to find the intervals of monotonicity of the function f, increasing and decreasing. Maximum time allotted for this question would be 10 minutes. Ideally, you should try to do it within 3 minutes. So you can pause the video, give the question a try, and then return back to have a look at the solution. So I hope all of you have tried it out. Now the answer to this question would be, it is a monotonically strictly increasing function in 0 to infinity. Now let us see how to solve this question. So concepts and formulas are once again the same. If derivative is greater than 0, then increasing nature of the function. If the derivative is less than 0, then it would be decreasing in nature. Now let us define fn x is equal to integral from 0 to x of the function t power 2n minus t plus 1 power n into logarithm of t plus 1 to the power 2n with respect to t, where n is any natural number. So obviously our question is simply f of 3 case, right? N equal to 3. So what we are now saying is that derivative we take fn prime x. So it comes out to be this much. Now clearly this function is continuous for all x in this range. So the sign scheme method would be applicable, because whenever we have a continuous function, we can always plot its sign scheme using the sign scheme method. The only thing is that it should be continuous. So how do we find the critical points then? So first of all, we equate it to 0 and find all the roots. That's the method that is followed for sign scheme method, right? So if you equate it to 0, fn prime x it is. So on doing that, you will get x power 2n is equal to x plus 1 power n into log of x plus 1 power 2n. Now, this actually gives us x square is equal to plus or minus x plus 1 into log square of x plus 1. Plus or minus can only appear for even n. If n is odd, then it would only be plus. But anyway, we are considering the general case. So let us say, even if it is an even number, then it can be negative also, so no problem. But this can't be equal, right? It is not possible, because positive can't be equal to negative. Clearly, this is a positive quantity. This is also a positive quantity. With a negative sign, it becomes negative. So positive equal to negative is impossible. So negative sign is anyway rejected, even if it is an even n. Okay. So we can only have the case x square is equal to x plus 1 into log square x plus 1. Now what we are doing is we are dividing by this quantity and then taking under root. So this quantity is equal to plus minus log of x plus 1. Now negative sign is once again rejected, because this is also positive. This is also positive, because x greater than 0 implies x plus 1 greater than 1. So logarithm of this quantity would be greater than log 1, which is 0. So this both of them are positive, so negative sign is rejected. So we can only have the positive sign. So this thing equal to this thing. Now transpose it to the other side, and we are calling that as g of x, which is x upon root x plus 1 minus log of x plus 1. Now g0 is clearly 0, and g prime x, if you find, it comes out to be this quantity. On simplifying and taking LCM, it becomes this, and finally this. But the square of anything is always positive, and denominator is also positive. So this entire thing is positive. So gx is an increasing function. So that would imply gx greater than g0, but g0 was 0 only. So gx greater than 0 for all x greater than 0. So if this quantity is always greater than 0, it can never be equal to 0, no matter what x you put. So since it simply means that fn x has no critical points, because when we solved the derivative equal to 0, we never got any x, right? So to find the sign of fn prime x, evaluate it at any x in this interval, right? Because we did not get any critical point. So from 0 to infinity, you can put any x. So let's say you put e minus 1, that comes out to be this much. And obviously that would be greater than 0. The reason is e minus 1 whole square would be how much? 2.72 approximately minus 1 would be 1.71, something like that. 2.718281828. So like that, from that we have subtracted 1. So its square would obviously 2.89 something, which is obviously greater than e, because e value is approximately 2.7 something. So that's what we are able to say, that since this is greater than e, we can say power n would also be greater than e power n. So basically this is greater than this, so the difference is positive. So the derivative is positive at this point. Since it is positive at this point, it will always be positive for all x in this interval, and that's what gives us the conclusion that fnx is MSIF in the entire interval 0 to infinity. So I would say this was a little bit on the easier side, and I hope you were able to follow through and understand the explanation. Make sure to like the video, comment down below what more you would like to see next. Share it with a friend, subscribe to the channel, and I'll see you all in the next one.